going to talk about the discussion and the conclusion in your science fair project. So we're going to start with some general information. The purpose of your discussion is to interpret and describe the significance of your results. So think of your discussion as an inverted pyramid. You're going to organize it from the general to the specific, linking your findings to first the theory, then the research that you found, and then you're going to interpret your results to see if they agree with the research and the theory. You're going to then explain the logic of your results to find any mistakes or unexpected findings or limitations or weaknesses of your experimental design, and you're going to finish with future improvements that might clarify areas of doubt. So for example, let's say your theory is water potential. You know that water moves via osmosis from areas of high concentration to areas of low concentration. And then you do some research and you find that in some research done in the University of Nebraska, they found that frequent watering increases the rate of transpiration as water moves from high to low concentrations, and that plants deprived of water can cause those plants to open up their stomata less frequently to avoid running out of water that they have already absorbed but not yet lost. So in your experiment, you found that frequent watering had no effect on transpiration. So here you see that your hypothesis is not supported and that you failed to reject your null hypothesis. So that means that what you expected to happen did not happen, and what you expected to happen did not agree with the research that you conducted, and it did not agree with the theory. So then you have to explain the logic of that. What happened to your experimental design? Were there any flaws? Perhaps the plant species that you used were too young, or not enough water was added, or not enough time was given to the plant to develop strong roots or enough leaves with stomata to allow transpiration. Or maybe there were some errors that included the plant stem breaking. So in the future, you decide to use different plant species because you conduct some research. And you find out that in that research, zinnias grow faster and sturdier, and they're going to develop quickly from seeds and will have strong leaves with many stomata. Your research also suggests that you're going to need to use 5 to 10 mLs of water per day per 5 seeds. So after you've organized your discussion in the form of an inverted pyramid, you must also be specific about certain information. So we're going to discuss 8 different points here in your organization that you must include. So you're going to state the purpose of your investigation or research question. Why are you doing this? Discuss the importance of your study and how it may be able to contribute to and/or fill existing gaps in the field. If appropriate, state how the findings from your study revealed new gaps in the literature that had not been previously exposed or adequately described. You're going to explain the scientific theory that guides your experiment. Remember that a theory is a carefully thought out explanation from observations of the natural world that has been constructed using the scientific method and which brings together many facts and hypotheses. Theories are reached via evidence and a consensus in the scientific community. What is the theory behind your investigation? Go ahead and explain that. And what do you expect will happen based on this theory? You're going to discuss how the research that you conducted helped you formulate a hypothesis. Remember that your hypothesis was guided by your research. So it was an educated guess, and the literature that you reviewed helped you formulate such hypothesis. So this part of your discussion is going to connect to the introduction, but you're not just restating the introduction, but you are actually moving the reader to a greater understanding. So you posed your research question in your introduction, but now you're moving the reader forward, and you are explaining how that research has helped you guide your experiment, has helped you formulate a hypothesis, and now you're using that to evaluate your results. You're going to state your hypothesis and if it was supported or not by your results. Clearly state if your hypothesis was supported or not. Remember that your hypothesis was an educated guess, therefore it might not be supported. Also, even if you think your hypothesis to be correct, it still might not be supported by your data, and that's okay. It's your hypothesis. You can say, it was not supported, or perhaps it was. State your null hypothesis and if you rejected it or failed to reject it. So you clearly state your null hypothesis, and then you're going to evaluate it based on your results to see if the IV is having an effect on the DV. Again, even if you think your null hypothesis should be rejected, remember that it still might not be, depending on your results, and that's also okay. You're going to then interpret your results by asking if your results agree or disagree with the theory and research conducted. That's what interpretation means. It's not just a restatement of your results, but you're constructing a logical argument that explains the data. It is neither absolute truth nor personal opinion. Interpretations are inferences about what the data means based on a foundation of scientific knowledge. Comparison of your results to other research should be made with appropriate literature citations. So you can include in-text citations again when you are interpreting your results. Maybe your data was wrong in comparison to theory, but as long as it is interpreted correctly, it is okay, even if it doesn't agree with theory. So what we're trying to say here is that even if you make a mistake, as long as you realize that you made a mistake, as long as you realize that your results are incorrect, and that they don't agree with your research in your theory, you can say that, and that'll be okay. What you don't want to do is have your data perhaps not agree with theory and you miss that completely. Then that's not okay. Number 7, you're going to discuss the logic behind your results to draw conclusions. Logic means discussing mistakes, unexpected findings, limitations, and weaknesses of your design. Your logic and the application of laws, principles, and theories are used to draw conclusions. You're going to include possible sources of errors. And we're going to talk about this more on the next slide, examples of systemic and random errors. Nothing trivial or vague as be more careful. You're going to explain any new understanding or fresh insights about the problem after you've taken the findings into consideration. You're going to identify potential limitations and weaknesses of your design. This is a difficult part because you're evaluating your overall design, and you're going to understand that perhaps there were limitations, or perhaps you didn't design your experiment the way it should have been designed. You're going to comment on their relative importance in relation to your overall interpretation of the results, and if necessary, note how they may affect the validity of the findings. It is far better for you to identify and acknowledge your study's limitations than to have them pointed out by your teacher and you not realizing that you made a mistake. And then finally, you're going to discuss what you can do in the future to improve your investigation. You're going to discuss an evaluation of the success of the experiment. Or perhaps possible procedural improvements and suggestions for future scientific studies. You're going to be specific about how future experiments might clarify areas of doubt in your results. You will have to do further research for this part. So you can't just say, I'm going to conduct another experiment in the future and try to do better. You have to be specific about what type of future experiment you will do and what kinds of things are you going to change in those future experiments. Now, what's the difference between systemic and random errors? And these are your possible sources of error. Now, no matter how careful you are, there is always an error there is always error in a measurement. An error is not a mistake. It's part of the measuring process. In science, measurement error is called experimental error or observational error. So there are two broad classes of observational errors. These include systemic errors and random errors. Remember that human error is not a source of experimental error. You must classify specific errors as random or systemic and identify the source of the error. Human error cannot be stated as experimental error. So let's talk a little bit about systemic errors. This is a consistent or proportional difference between the observed and true values of something. So these errors can often be avoided by calibrating equipment, but if left uncorrected, they can lead to measurements far from the true value. These errors do not average out over repeated measurements. So some examples of systemic errors might be forgetting to tar or zero a balance. So that's going to produce mass measurements that are always off by the same amount. And this is why we mean as them being consistent or proportional. Perhaps you did not read the meniscus at the eye level for a volume measurement, and you're always going to get an inaccurate reading. The value will be consistently low or high depending on whether the reading is taken from above or below the mark. Or perhaps you had an improperly calibrated thermometer that may give accurate readings within a certain temperature range but become inaccurate at higher or lower temperatures. Examples of random errors. These are errors that have a chance difference between the observed and true values. So these errors are unavoidable but cluster around the true value. The main reasons for random errors are limitations of instruments, environmental factors, and slight variations in procedure. Because random error always occurs and cannot be predicted, it's important to take multiple data points, which you have, and average them to get a sense of the amount of variation and estimate the true value. So some examples of random errors is measuring the mass of a sample on a balance that may produce different values as air currents affect the balance or as water enters and leaves the specimen. And this is a common mistake that I see often. Taking a volume reading in a flask and reading the value from a different angle each time are examples of random error. So what common mistakes should you avoid when writing your discussion? Well, don't over-interpret the results. Interpretation is a subjective exercise, therefore be careful that you do not read more into the findings that can be supported by the evidence. You go with the evidence of your results that you've gathered. Remember that the data are the data, nothing more, nothing less. Don't write two results sections. One of the most common mistakes that you can make when discussing the results of your study is to present a superficial interpretation of the findings that more or less restates the results section of your paper, which you already wrote. Obviously, you must refer to your results when discussing them, but focus on the interpretation of those results. Do they agree with research? Do they agree with theory? And what's the logic behind some of the mistakes that you might have made? Remember the mechanics of the discussion. Use a minimum of 1 to 3 pages to write up your discussion. It has to be double-spaced, 12-point type font, passive voice. Use the present verb tense, especially for established facts. However, refer to specific works and references in the past tense. For further help, remember that you can go into the Science Project Help Canvas course. Make sure you are enrolled. You should be by now. Reach out to a Science Fair mentor directly through their posted email or ask a question on the discussion board for this deadline. Attend lunch labs and ask your questions. And always a knowledgeable, helpful teacher is there every day, every lunch for you. And ask any of your teachers as well. I'm sure they'd be happy to help. Thank you for listening.